If you could, please, let's pass that forward. Just make sure your name is on it. Okay. I got it. I'm going to put this stopper here. All right, got yours, guys? Okay.
It's right here. I did it right here. So.
That's fine. Yeah, just put your name on the front somewhere, and yeah, there you go. That'll work. Got yours here? It's 14th September. Okay, thank you. All right, thank you. Yeah, I'll come back. Right here. Thank you. Thank you. I don't. You have a stamp? There you go.
Yeah.
That's fine. Okay, thank you. Anybody else? Okay, so I'm going to start posting the ebook up here so I don't have to write the problems down if I'm referencing the problems from the book. So on your homework assignment for last time, I said not to do everything in 4.2, right? Is that correct? Pardon? Well, 1.2 you were supposed to do, right? And then was it, 4.1. That's what I meant. I meant 4.1. So 4.1, I said go ahead and just take a look at it and do what you can. So what we did last time is we solved systems of equations using substitution, right? And today we are going to do elimination, and then I'm going to do a couple of more word problems, and then we're going to look at matrices and what are called augmented matrices and how we use those to solve systems of equations. So that's kind of the plan today. And I will get back to these word problems. So I'm going to just bring up a blank slate here for me to write on. Let's talk about elimination. This is our second method to solve for solving systems of linear equations. All right, this is our second method. And so on an exam, I don't care which method you use. All right, you use the one that you feel most comfortable with. On the homework, it will tell you which method to use. But again, I actually don't care what method you use. All right, so even if the homework says use substitution, if you prefer elimination, use elimination. If the homework says use elimination and you prefer substitution, use substitution. But let's do a problem and let's just see kind of the difference between elimination and substitution and where you might prefer this over substitution in some cases. All right, so let's do a system. Let me get one out of here that asks you to do elimination. Oh yeah, this is a good one. Okay, so how about 3u minus 2v equals 12, and then 7u plus 2v equals 8. And this is our system of equations. Now notice, does anybody notice something different already with this system that we have not used up to this point? The two different variables, right? Normally we've been using x and y, but now we're going to use just two arbitrary letters, u and v, all right? And so what we're trying to find here is a value of u and a value of v which make both of these equations true simultaneously. Now, let's try and approach this with from the perspective of substitution, which was last class. You would pick one of these, right? And you would choose which variable you want to solve for. And does anyone see a problem with that? You're going to get fractions, no matter what you do, right? Like if I take this first equation and I try and solve for u, I'm going to eventually have to divide through by 3, won't I? That's going to create fractions. If I solve for v, I'm going to eventually have to divide through by -2. Again, I'm going to create fractions. And the same thing if you go with the second equation. Solve for u, you'll have to divide by 7, you create fractions. Solve for v, you divide by 2, fractions. So in this case, unless you're very comfortable working with fractions, which most students are not, they want to avoid it if they can, then you go to possibly using elimination. And the way elimination works is that you're going to look at your equations and then you're going to look at your variables. All right, so let's look at the u's. I have 3 u's here and I have 7 u's here, right? What I'm going to try and do is make both of these numbers not the same but opposites. In other words, like if that's 3u, I would want this to be -3u. All right, the opposite. So do I have that right now? Are they opposites? No, hold on, I've got to sneeze. I think I do, hold on. Okay, I think it went away. All right, now look at the v's. I have -2v and I have +2v. These are opposite of each other, right? And that's what we want. Now, it's not always going to be that one of them is opposite. This first example, they are. But you see, that's what I'm looking for. I'm looking for these variables to be opposites. Need these to be opposite. And what I mean by opposite is that they're the same number but different signs. One of them's positive, one of them's negative. So if I have that, which I do right here, right? Then all you'd have to do for elimination is add the 2 equations straight down. Just add them down. So what would you get if you take 3u and you add 7u to it? 10u. You get 10u. Everyone understand I'm just adding straight down? And then add -2v and +2v. Those should cancel, right? So I get plus nothing. You don't need to write plus nothing, but just so you know that this came from the fact that the v's canceled. And then I have equals, and then now I add straight down here, and I get what? 12 and 8 is 20. So really this equation is 10u equals 20. So what's u? 2. Just divide both sides by 10. U is 2. I already know what u is, don't I? Once you know what u is, you now need to go back and try and find v. And to find v, you get to pick any equation that you see up on the board, any of them, and replace u with 2. But only pick one of them. So how about we pick this top one, all right? Let's rewrite it. So once I've done that step, I'm going to take the equation 3u minus 2v equals 12, and I will replace now this u with 2. So 3 times 2 minus 2v equals 12, and that means that 6 minus 2v is 12. And now you can just move things around, solve for v, right? So subtract 6. And divide by -2. What would you get for v? -3, right? Dividing both sides by -2. So v is -3. Now I'm going to write my answer. I'm going to write it in 2 different ways. I'm going to write it first, u equals 2, v equals -3. Okay, that's one way I could write my answer. Or I could also write it as an ordered pair to -3. All right? It's just we understand here that the u is this one and the v is that one. Kind of like the x and the y. Understand? So do you see how this method was much cleaner and faster and no fractions compared to what substitution would have been? Okay, so in my opinion, you should have both methods like in your toolbox ready to go. Because if you get like married to just one method, then you get a problem like this and you're going to be struggling with the fractions. All right? Let's do another one. That one was a little too easy. It was easy because they canceled right away. Let's see something that does not cancel right away. And yeah, I've got a good one here. Okay. 2x minus 3y equals negative 8. And then 5x plus, hold on a second. Y is 2, 6. I want to change the problem a little bit. Hold on. Let's make that 4x plus 5y equals 6. There we go. All right, so you have a system of linear equations here, right? Would you want to use substitution? You could, right? But you're going to have fractions, right? So what's the thing that's tipping you off that you're going to have fractions? Yeah, if you've got numbers out in front of your variables that are anything other than 1, then you know that you're going to have fractions when you start dividing through. So if any of these have a 1 in front of them, or it's just the letter by itself, then you might be thinking substitution at that point. But if they don't, if they all have different weird coefficients, then you start maybe thinking elimination. Now, if I add straight down right now, am I going to get anything to cancel? No, this is going to get 6x. That's no good. Here, if I add that, I'm going to get 2y. So that's not going to, they're not going to go away. And you need one of them to, when you add down, you need one of them to, I don't know, eliminate, right? You need to eliminate one of them, which is why we call it elimination. So how can I force this to happen? So what we need to remember is that anytime you have an equation, right? Anytime you have an equation, you can always add or subtract the same number from both sides, or you can multiply or divide the same number on both sides, right? And you maintain the equation. So let's look at the x's. Is there a way that I could make those go away? Could I change one of these to make them opposites? What would be the change you could use here? If you multiply this number right, or this right here by negative 2, it becomes negative 4x, right? And then it would be opposite of this. That's what I'm going to do. I'm going to put a negative 2 out here. I'm going to circle it. And I want you to imagine that what you're going to do is take this entire equation, the first one only, and multiply every single one of the terms. And that means the other side also. You have to do both sides of the equation. Everything gets hit by negative 2. And I'm going to rewrite the whole system over. So this system now becomes a new system. It's negative 4x, what? Plus 6y equals positive 16, right? And then the second equation, we didn't touch it, right? Like that. We have not changed the actual problem. Like we are going, whatever, if there's an answer to this, it's going to be the same answer. Because what we did to the first equation was we did the same thing to both sides. So we haven't screwed it up, okay? It's still the same equation. Now when you add straight down, good things happen, right? So let's go ahead and add straight down. Go here and you get 0. What about here? 11. So we're going to get 11y equals 22. Solve for y. So divide both sides by 11, and you get y is equal to 2. I don't know why I put a negative there. No idea. Okay, so y is equal to 2. We know what y is. Now we have to go back and get x. And which equation do you want to plug in the 2 into? Any of them, right? It doesn't matter. So you want to go to the bottom one, this one right here? Okay, so we're going to grab this one. I always recommend that whatever equation you go back and plug this into, I like to grab one of the first two. I don't like to grab any of the ones that I've changed because I might mess it up. Like this, there's more room for error if you go back to something that you've already manipulated. Here you know these equations are true because that's what was given to you, right? So you can't really mess those up. All right, so let's write down that equation. The second equation is 4x plus 5y equals 6. And I'm replacing what with what? Y with 2. So 4x plus 5 times 2 equals 6. 4x plus 10 equals 6. 4x equals negative 4. Subtracting 10 on both sides. 6 minus 10 is negative 4. Divide both sides by 4. X is what? Negative 1. So that's your answer. Now, as an ordered pair, it would be negative 1, 2. What do y'all think of this? Okay? You like it? It's okay? All right.
You say we're not changing it from going to negative 4x plus, but I mean, how are we not changing it? How? I mean, from that negative 4x, are you able to just factor it out and then it goes back to the
Yeah.
last one?
Let me try and convince you with something else, okay? Let's say that I have 2x plus 1 equals 5, and I ask you to solve this equation, all right? You would subtract 1 from both sides. You get 2x equals 4. You would divide both sides by 2, right? You get x is 2. Right? That okay? Now, let's take that equation, 2x plus 1 equals 5, and let's just multiply everything by some number. So let's multiply everything by 3. How about that? So if I multiply that by 3, I get 6x. Multiply that by 3, I get that. Multiply that by 3, I get this, right? Now let's solve this equation. Subtract 3 from both sides. You get 12, right? And divide both sides by 6, and you get 2. And these answers are the same, not because coincidence, it's because as long as you multiply both sides by the same number, the solution doesn't change. That okay? I mean, I don't know if that's convincing. I'm just trying to show you evidence. Yeah. That's why we're allowed, if you have an equation, that's why you're allowed to multiply both sides by the same number.
So that's how you know if like you're wrong, if the answers don't match up, then they're not the same equation. Then
If the answers aren't the same here, then something went wrong with your algebra. You either didn't multiply through correctly, or in your solving, you messed something up. But the main thing is that if you have an equation, whatever its solution is, will not be impacted at all if you multiply both sides of the equation by the same number. All right, so now we have this method, right? And I'm going to give you one more example. This one, though, I'm going to make up, so it's going to come out of my head, so I can already tell you right now the answers are going to be kind of ugly, all right? All right, so how about this? How about 3x minus 4y equals 10? And I might be able to make this work. Hold on. Yeah, I'll make it a really, nah, who cares? It'll take too much time. Let's do this. 5x plus 3y equals negative 6. So if you have that and you're looking at it, you're like, all right, what do I do here? We can already probably throw substitution to the back burner, right? Because all the numbers in front are not 1. So now we try and eliminate something. Do you see the problem? Do you see the issue? There's nothing I can multiply 3 by to get 5 other than a fraction. And there's nothing I can multiply this by to get 3 without using a fraction. So I'm kind of like having some trouble figuring out what number to multiply through by. Do y'all see it, the difficulty here? But I'm still going to force it to happen. So watch what I do. Just see me do it first, and then you'll be like, oh, okay, I see what you did. All right, so how about this? 5 here and negative 3 here. What's wrong with me multiplying them both by numbers? Right? I mean, I could do that. If I can multiply the first one by a number, I should be able to multiply the second one by a number. So what have I done here? What am I going to create when I pass that 5 through? What's that first term going to be? 15x, right? And then now look at the bottom. What's the first term going to be here? Negative 15x. So all I really did was I looked at the 3 and the 5. I said I'm going to put a 5 here and a 3 here, and then I just changed the signs of one of these so that they would give me opposite. I could have done negative 5 and positive 3. That would have worked also, but I just chose to do it this way. Now let's see what happens. 15x, what's the rest of this? Minus 20y equals 50, okay. And then the next one, negative 15x minus 9y equals 18. Good, so what I've done is I've created the opposites, and now when I add down, I should be in business. And yeah, it's going to be ugly, but what do you get when you add down? Negative 29y equals 68, right? And let's go ahead and break out our calculators because I don't believe that goes in there nice. It's not a nice integer. So I'm dividing both sides by negative 29, right? 2.34, roughly, and it's negative. So negative 2.34. Let's go just 2 decimal places is good enough. And now what? Take that answer, plug it into any equation you want, right? And again, I'm just going to go back. I'll just grab the first one. There we go. And I'm going to replace y with negative 2.34. So 3x minus 4y, so negative 2.34 equals 10. Okay, so replacing the y here with that answer.
So you don't go back to what you changed it to. You go back to your...
You can go back to this.
Okay, okay.
You can. I always like to go back to the original. Because usually the numbers are smaller over here because you've come through with like a 5 and made it bigger. So the numbers are smaller. Doesn't matter though, you get the same answer. So 3x, and then I have to multiply that times negative 4, so what, 9.37, 9.38 if you round. It's really not that important to me that with this rounding, if you put 9.37, that's okay. I'm not going to take off for that. And now this is just a little linear equation, move things around, divide through. So I'm going to take 10, I'm going to subtract 9.38. So I get 3x equals what is that, 62? And then divide that by 3, and you get 0.2. No. What did I do? What?
Yeah, isn't the point 9.38 supposed to be a negative?
I subtract on both sides, right? Well, this was minus 4, right? But our answer was negative. So minus a negative becomes plus. Then I subtract it on both sides. .21 is good. It's like 0.206 or something like that. And this is an approximate answer. Both of these are approximates. So as an ordered pair, it's approximately 0.21 and then negative 2.34. We good? Okay, let's do one more problem, and then we'll get to a word problem. Uh, 2.75x minus 1.3y equals 4.5, and 3.15x plus 5.2y equals negative 2.7. Ugh, right? This is messy because all those decimals. So I'm going to choose to do something here that's going to eliminate all the decimals. Not eliminate like cancel, but I'm going to change the problem where I no longer have those decimals. And so when I look at this, I would actually need to move this decimal place to the right 2 places to make that a nice number, right? To move a decimal to the right 2 places, how many? What would you have to multiply by? 100, right? So if I move this over 2 places, I'll have a nice number. If I move this over 2 places, I'll still have a nice number, right? 2 places, it'll be 450, but that's still a nice number. 2 places, 315, 2 places, 520, 2 places, 270. So it looks like I can move everything 2 places and I'll be good, right? Now, could I go 1 place, just 1 place over? If I did that, this would be 27.5. I'd still have a decimal. So I don't want to go 1 place over. I want everything to go 2. 3 would be too much, right? I could do it, but I don't need to. So really what I'm doing is I'm multiplying. I mean, technically, mathematically, what you're doing is you're multiplying the top by 100 and the bottom by 100. And that's going to allow us to rewrite this system. So what is this system now going to be? 275x minus 130y equals 450, right? Every decimal got moved to the right 2 places. Second one, 315x plus 520y equals negative 270. Everybody agree with this? Understand it? Okay, now you're back to where we were like on the previous problem. No more decimals. Let's try and figure out what we can do to eliminate. I don't want to use substitution because these are all numbers in front and it's going to be so hard for me to solve for x or y. So let's try and eliminate the x's again. So what would I need to multiply both the top and the bottom by here? It's going to suck, but it's what you got to do. So what do I multiply by? What on the top and what on the bottom? Did y'all pick up from the last example how I did it?
Like a larger, I mean, like 500 number? Probably the same number.
We use the same number, right? So up here, I'm going to multiply by this number, 315. Okay? So this number I'm going to put here, 315. And then down here, I put what number? 275. But I need it to be negative because when I do 315 and 275, it'll be a positive number. And negative 275 and positive 315 will be a negative number. And I need them to be opposite, right? Is that clear what I did? Now don't forget, you need your calculator. You're going to have to go through and do that number through to all. We're going to have some big numbers here. But I think we'd rather have big numbers than decimals still.
Just do the 520 and the 130.
You could have done that also.
The 130 goes into 520 4 times. Yeah, just multiply the top.
Oh, is this a, oh, it just so happened. I wasn't paying attention to that. This is a perfect, if I multiply this by 4, I get this?
Yeah.
Well, you know what? Most likely that wouldn't happen on a real problem. So let's just continue with this. But I'm glad you noticed that. That would be much cleaner. All right, so I'm doing 315 times 275. Wow, big number. So here's my new system. 86,625x. Then I have to do 315 times 130, which is going to give me minus 40,950y equals, now I'm doing 315 times 450 is 141,750. That makes sense? That's okay? I mean, like I said, it's going to suck. But all right, so when you do these two, I'm going to get the same number I have here. It's going to be 86,625, but it's going to be negative 625. All right. Who's got the next number for me? The negative 275 times 520. Negative what? 14,000. 143,000?
Yes.
Then what? That's it, even?
Negative.
Oh, just 143,000?
Yeah.
Okay, nice.
Why?
Y. And then equals, now we got to do negative 275 times negative 270. 74,000? 74,250. Okay, are we all in agreement here? Anyone disagree who's calculating on their own? No? Okay, add straight down. These are going to go away, right? When you add down, you got to add these two together. So we have two negatives, right? So when we add those down, it's going to stay negative. And we get, let's see, 4950. Negative 183,950 equals, now we add down over there, $216,000 straight up. I forgot my y here, sorry, that's y. And now you divide both sides by negative 183,950. $1.17 negative? Okay, so y is equal to negative 1.17. There we go. And then x, how do we get x? Plug it into any of these, and I'm just going to go back and grab this first one right here. I'm actually going to use the decimal one because I've already got decimals, so I'm not too concerned about it. So I have 2.75x minus 1.3 times negative 1.17 equals 4.5. And then you work this out. Getting 2.75x plus 1.52 equals 4.5. I'm subtracting 1.52 from both sides, right? So 2.75x equals 2.98, and then I divide. 1.08. We found x and y. Okay. Now, for those of you who may not have liked this, especially because I made the numbers real big, I just want to point out that you could have done this to start the problem. You could have just done this, not moved the decimals at all, and just done like 3.15 here and negative 2.75 here. So this one here, opposite in sign. And if you would have done that and distributed through, we would have got to the same answers, but you would have had decimals the whole way. All right, you would have had to just work with decimals. It's okay, you could do that. Or you could have noticed that these are, just multiply that by 4, but that was just by chance. I just wrote the problem down, I wasn't paying attention. All right, that's it. Any questions on elimination?
If we would have multiplied by 4, we'd have to do everything by 4?
Just the top one.
Top one?
Just the top one, because this times 4 would give you negative 5.2. And then it would have canceled, 5.2y, and then it would have canceled with this. So that would have been the only thing we had to do. Okay. Let's bring up a word problem out of your homework from 4.1. I'm going to do a homework problem. So 4.1. let's do 71. So I'll bring it up here, maybe. Go a little bit bigger. See if everyone can read this. All right, can you all read that okay? Number 71, break-even analysis. A company markets exercise DVDs that sell for $19.95, including shipping and handling. The monthly fixed costs for advertising are $24,000, and the variable costs are $7.45 per DVD. Find the cost equation and the revenue equation. So there's two different equations we have to find here. All right? So let's talk about the cost equation. And let me see how far I can go over here. I can go to here. What's the cost equation? So how much does it cost this company to manufacture these DVDs? Okay, so let's call it C. Cost equals, you said 24,000? That's your fixed cost, right? That never changes no matter what. They got to fire up the machines. They got to get the people in there, right? Okay, so that's 24,000. And then what else? Plus what? 1995 or 7.45? Which one is it? 7.45. So $7.45 per DVD, right? We can call it X. So if they manufacture no DVDs, zero, then they're going to have their fixed cost. If they manufacture one DVD, it's going to cost them $7.45. So when it said here variable cost is this, that's why that number went into our cost equation. Understand? That's it. That's our cost equation. This gives us how much money it's going to cost us to manufacture X DVDs. Now find the revenue equation. Revenue should be the money coming in, right? That's our revenue equation. So how much are they going to, assuming that they sell everything they make, everything that they produce, how much will they make? $19.95, right? They're going to make $19.95, and that's it? X. Because X is how many CDs they make, right? So if they don't make any CDs, they can't make any money. They make one CD, or DVD, sorry, DVD. They make one DVD, they can only make that much money off of it, right? All right, so next, this is part A, right? We're done with part A. Part B. How many DVDs must be sold each month for the company to break even? For them to break even. What does that mean to break even? We need the revenue and cost to be the same, right? So what we want to do is set revenue equal to cost. So set 19.95x equal to 24,000 plus 7.45x. Set your revenue and cost equal to each other. And now, what type of equation is this? It's a linear equation. How many variables? One. Okay, so we should be able to solve this and get an answer. So solve for x. Subtract 7.45 from both sides. 7.45x. Over here it goes away. And then what is that right there? Bless you. What's this? 12.5x equals 24,000. And now divide both sides by 12.5. And what do we get for x? 1,920. So what does that mean? Tell me in words what this means. What does x equals 1,920 mean? Yeah, they need to sell 1,920 CDs in order to break even. A little bit more than that, though, is that's how many they need to manufacture and sell, right? So like if they manufacture 20,000 CDs and only sell this many, they're not going to break even. This break-even point gives you not only how many they need to sell, but how many they need to manufacture. Understand? And that's normally impossible for a company to do, right? When you have a company like Apple, you know, I like using Apple because most people have iPhones, right? So when they go and release a new iPhone, they cannot predict exactly how many they're going to sell, right? So the analysis of trying to find a break-even point is a little harder. Now, do you think Apple really cares about break-even? Yeah. No, they don't even talk about break-even. Their profit is so high. So, all right. All right, did we use a system of equations for that? Did we use a system of equations to solve that problem? When? No? Yes? R equals C, but was that two equations, two unknowns? When R was equal to C, right? Each equation had just X in it. Do you agree? So we never had to use substitution or elimination, right? So, but that is actually in this section. I mean, like in your homework, here was a problem that did not require substitution or elimination, but it was in the section for substitution and elimination. So just be aware of that. You know, each problem is different. So let's take a look at number 79. I'm sorry? Oh, what was C? Was it graph? Yeah, let's not worry about the graph. 79. Electronics. Keep this a little bigger.
What number was the question that we just did?
I believe it was 71. Okay, a supplier for the electronics industry manufactures keyboards and screens for graphing calculators at plants in Mexico and Taiwan. The hourly production rates at each plant are given in the table. How many hours should each plant be operated to exactly fill an order for 4,000 keyboards and 4,000 screens? What? What? All right. What are we being asked to find?
Keyboard and screen. Or the
Amount of hours it takes.
The hours, right? How many hours for each plant? So we're going to have two answers, right? It'll be how many hours the Mexico plant needs to be producing things, and then the other answer is how many hours the Taiwan plant needs to be operating. Do you understand that part? Okay, so I'm going to put that here. We want two things. X, which will be equal to the number of hours the Mexico plant operates. And then Y, which is the number of hours the Taiwan plant, right? Operates. That's what we want. We want to solve for two different things. Now, how can I understand what this table is telling me? I mean, what does this mean? Mexico, 40 keyboards, 32 screens. What does that mean? Just that first line up there. What does that mean? That's how many, so I'm covering this one up. This first row says that in 1 hour, the Mexico plant can produce 40 keyboards and 32 screens. All right? The second row says in 1 hour, the Taiwan plant can produce 20 keyboards and 32 screens. So looks like the Taiwan plant doesn't have as many people working there or something, right? It's not as efficient as the Mexico plant. So for our company, what we need is we need to utilize both plants, and we need to figure out how many hours they need to operate so that we get exactly 4,000 keyboards and exactly 4,000 screens. How many hours? So how can I figure that out? I'll give you a hint, and the hint is that you're going to need a system of equations because you have two things you're solving for, right? X and Y. So you should be able to come up right now with two equations. Can anybody come up with the two equations?
40x plus 20y equals 4,000.
Okay, I'm going to write that down. 40x plus 20y equals 4,000. Can you explain to us why you came up with that equation, and then we'll see if the class agrees whether or not that's a good equation.
They want 4,000 screens and they want 4,000 keyboards.
Okay, so you're just looking at keyboards right now. Okay, so you're thinking, I've got just keyboards right now. Go ahead.
And so then the Mexico plant makes 40 per hour, which would be 40x.
Okay.
And the Taiwan plant makes 20 per hour, which would be 20y. So we need the hours in both of those plants plus how much they make to equal 4,000.
Okay, yes, this is right. So you have, the thing that you have to understand is that you're not going to be looking at just the Mexico plant and then just the Taiwan plant. What you're really looking at are keyboards and screens. So if the Mexico plant can make 40 screens per hour, then they can make 40 times X screens, can't they? X is the number of hours. So 1 hour they'll make 40, 2 hours they'll make 80, 3 hours they'll make 120. But we want that added together with the number of keyboards the Taiwan plant can make, which will be 20y, to be equal to 4,000. Does that look okay to you? I guess what I would be afraid of seeing is this. What would this mean? This would mean 40, right, keyboards per 1 hour or per hour for Mexico. And then this would mean 32 screens, but this is not Mexico, right? Y is Taiwan. And so this would not make any sense. This equation would not make sense. Y'all see that? All right, now what would the other equation have to be? And I'll put here, this was our keyboards. It would be using that information, right? 32x plus 32y equals 4,000. All right, there we go. Do it. We'll give you a couple of minutes. Give you, what, 10 minutes maybe at the most? You all work it out. I want to come around. I want to see everyone has a solution, all right? So when you get an answer, I want you to raise your hand. You're free to use substitution or elimination. Either one. You can talk to each other. There's no penalty. Let me get the sign-in sheet going around. We still have a little more to do, but go ahead and sign in. Sign in for both today and Tuesday. Let's see. I'm just going to tell you what the correct answers were for this. And hopefully you can get that on your own. If not, later on today, try and do this. X is, what was it, 50? Or no, 75? Yes. X was 75 and Y was 50. And what does this mean?
It means that the screens is 50 and what was the other thing, TVs or whatever?
Keyboards and screens.
Okay, so yeah, the keyboards is 75 per hour.
Sure? Look back up here. What do these answers represent?
X is Mexico.
What about Mexico? How many hours that plant needs to be running? You need to have the Mexico plant operating for 75 hours. You need to have the Taiwan plant operating for 50 hours. When you do that, you will produce your 4,000 keyboards and screens between the two plants. Okay, all right? Okay, yeah.
Because if you mess one thing up.
Oh yeah, yeah. If you mess up one thing when you're solving, then it becomes, really a pain in the butt. All right, so I thought it might be useful at this point to show you something, because in the real world, solving a system of equations like this is not something that you would do by hand, right? In the real world. You would use something to do it for you because of all the errors that you could make, right?